Now let's go over the binomial theorem. So remember, a binomial means basically there's two terms. So one term, two terms is the idea. Our goal is to expand this binomial for any integer n, well, any positive integer n. So I have a few examples down here. You may want to take a second to expand those. So here's x plus 2 squared. So that, of course, means you have a product of the two binomials. So then you got to distribute each term like that. Well, it's actually that and that. 1, 2, and then 3, 4 is how you distribute. You'll get this, and then you combine like terms in the middle, and you get that trinomial. Then you could keep going like that. Here's another one, x plus 2 cubed, meaning basically you're taking this and multiplying it by one more. So here's x plus 2, and then multiplying that out. Then you combine like terms, which are the ones in the same highlighted color, and you get this. And you'll realize real quickly that that is a bit cumbersome to do, and it takes a while and it's tedious. So let's maybe try to figure out a pattern and a way to do this. So we don't have to do it ourselves. We're going to just use it. Here's some more generic forms. So just a plus b and a plus b cubed. I'm sorry, a plus b squared, a plus b cubed, and how it multiplies out with just specific terms. Okay, now we want to talk about some definitions. We talked earlier about factorial. Okay, so remind you what n factorial is. So it's n minus 1, etc., all the way down to 3, 2, 1. Okay, and then we want to define what's called a combination of n things r at a time. So it's called a combination, or you read it as n choose r. So this is what the n choose r would look like. So that form is n choose r. Okay, so we're going to use that when we do the binomial theorem. So n choose r is n factorial over r factorial times n minus r factorial. Okay, so that's just, it's easier just to do one, of course. Let's try 5 choose 2. So it's not, don't put a bar right there, it's not a fraction. So the top is your n, the bottom is your r, so it's 5 factorial over r factorial, and then 5 minus 2 factorial. And then you simplify it. This is a factorial, but 2 factorial is just 2 times 1. So you don't want to actually multiply out 5 factorial, you want to reduce it. So I did all this reduction step here with before I multiplied anything. So 5 choose 2 is 10. So it's another way in statistics, if you ever have to do that or did that, it's the number of ways to arrange 5 things 2 at a time. I'm not going to get into that, but that's where it's also applied. Then we have some special cases. The special cases are ones that come up that you just, it doesn't matter what the number is, you always get the same thing. And remember that, remember, whatever, that 1 factorial is defined to be 1, and 0 factorial is defined to be 1. So when you have the n choose n, you're going to get n factorial over n factorial, and then n minus n is 0 factorial. So all that reduces to 1. N choose 0, same thing, reduces to 1. Spend some time studying how that works. All right, then n choose 1 is n factorial over 1 factorial, n minus 1 factorial. So what happens is when you expand n factorial, you can expand it to n times n minus 1 and then say factorial. And then these will reduce to 1. So so if it's just like 5 choose 1, oh, I did an example right here. If I have just like 5 choose 1, it's just 5. Okay, and you can work it out, but you don't have to actually do all these steps because it's always this form. It's a special case. And then 5, or not 5, but n choose 1 less. So n choose n minus 1. This is a little more work to look at. Just take a moment to go through that. You get n as well. So 1 less than 5 would be 4. So 5 choose 4. Don't even have to look at this stuff. We know it's going to be 5. Okay, but I do work it out. Okay, so I had a number of examples for the special cases down here. So 6 choose 0 has got to be 1. 6 choose 1 is 6. 6 choose 5 has to be 6. And 6 choose 6 has to be 1. Those are your, basically what happens, those are your outside coefficients. All right. Now, if you do 6 choose 2, here's one you got to work out. So it's 6 factorial, 2 factorial, 4 factorial. And so you expand 6 factorial into 6, 5, 4, and then it keeps going. So 6 choose 3, or I'm sorry, 6 choose 2, didn't finish that, is this product, 3 times 5, which is 15. 6 choose 3, again, work it out, simplify, and you get 20. Okay, so I went through that fast, but spent some time going through those problems yourself. This is the definition of the binomial theorem, or the theorem itself. It's not really definition, it's a theorem. So if you have a, b raised to the n, this is how it expands, just like that. And so it takes a little bit of time to go through it, but that's the best way, I think, to look at it and use it. And basically that's all we're going to do is expand stuff out. So we'll do a couple together, and then I'll probably just have you do some on your own. All right, so suppose, how about we do the one above that was, what was it? It was x plus 2. So we know what that is. We just did it. Well, we didn't really do it now, but it's up here. So let's expand this one and see what we get. Should be exactly the same thing. So it's a good habit to test what it is. So in that form, what is n? Okay, so we know n is equal to 3. So this will expand to, and I'm going to write it out, although when you have n choose 0, what is that always going to be? And those are special cases at the ends. So those are always going to be 1. All right, but I'll write it out this time. So you say 3 choose 0, and then it's the variable, this is like your a, right here, that's like a, and this is like your b. So it's x to the 3rd. Then it's, now the b is gone, but it's really times 2 to the 0, which is just 1. So then it's plus 3 choose 1. And then what you're doing then is you're stepping down in this exponent, so that will now be a 2 over here. And then you're stepping up in this exponent, so that'll be a 1 over here. So it's 2 to the 1st. The sum of those always has to add to n. So if you go back to here, right, where'd it go? Yeah, well, it's right above me. This sum, it's not as obvious here, but that sum always adds to n. N, right, just those always add up to n. All right, so where was I at? So 3, 0, 3, 1, and then plus 3 choose 2. And then it's x, this goes down, so it's first power, times 2 to the 2nd. So it's 2 plus 1 is 3. plus 3 choose 3, and then it's x to the 0 times 2 to the third. And then it's always at least one or two more steps to simplify. So this is just x cubed, and this is a plus. And then 3 choose 1 is just going to be 3, and then times the 2, x squared, plus 3 choose 2, well that's just 1 less than 3, so that's got to be 3 as well. And then times 4, 2 squared is 4, times x. And then plus 3 choose 3 is 1, x, so it's just 8. And then one more step to simplify, combine like terms. X cubed plus 6x squared plus 12x plus 8. So, is that the same as the other one? Let's see. There it is. Right there, you can see it. I think you can see it. Okay, so this is the same as this. Okay, so that one's questionable which one's easier, but once you get up to higher, probably one more power, and you don't want to be doing it by hand, you use the formula. All right, so let's look at something a little more complicated. So we have basically 2 more to go, and then it's not going to be any more difficult than that to expand these out. So next one, try these, and then I'll probably pause it and write them up. So try that one, and then try this one. So it's a squared minus 3b raised to the 4th, and the other one was x minus 2y raised to the 5th. So I will give you the solutions basically on those, but follow the pattern, study the book a little bit before you try these. And then we will go on to one more section, mathematical induction, and that'll be it for the class.